Hello, we are asked in this problem to find the derivative of the function secant of x to the power tangent of x. In fact, this problem involves the exponentiation where the base function is secant of x, and the exponent function is tangent of x. In order to compute its derivative, we need to apply the chain rule, and the logarithmic differentiation technique. In this problem, we have to compute the derivative of secant of x to the power tangent of x. It comes that, this function can be seen as an exponential function because it is obtained by raising secant of x to the power tangent of x. In this case secant of x is seen as the base and tangent of x is the exponent. We will have to use the fact that the exponential and the logarithmic functions are inverse functions. Then apply the chain rule to find the derivative. In order to simplify this expression, we will use the properties of the exponential and logarithmic function. We know that, the exponential of log of x is equal x, which is also equal to the logarithm of the exponential of x. Observe that, we will also have to use the chain rule. It is known that, the derivative of the composition of two functions u of v of x is equal to v prime of x times u prime of v of x. Therefore, we express f of x as exponential of logarithm of secant of x to the power tangent of x. Using the properties of the exponential and the logarithm, actually f of x equals exponential of tangent of x times logarithm of secant of x. As a matter of fact, we are using the fact that the logarithmic of x to the power y is equal to y times the logarithm of x. Now, we can take the derivative of both sides and use the chain rule. We know that, using the chain rule, the derivative of f is equal to the derivative of the product tangent of x, times, logarithm of secant of x, times exponential of the product tangent of x, times the logarithm of secant of x. Observe that, in order to find the derivative of the quantity tangent of x times, logarithm of secant of x, we need to use the product rule. In this case, the derivative is tangent of x, times, the fraction secant of x times tangent of x over secant of x, plus secant square of x, times logarithm of secant of x. So we have the expression of f prime as follows. This final expression can also be given as follows, f prime of x is equal to the quantity tangent of x, times, the fraction secant of x times tangent of x over secant of x, plus secant square of x, times logarithm of secant of x, times secant of x to the power tangent of x.